Hey everybody, good morning. How are you? So good to see you again. Happy Sunday. Hope that you're doing well in your part of the world. It's been a while since we've connected, but it's good to get back to our Sunday series and get talking about, about data science, right? We're going to keep on learning about data science and all the different aspects that are involved. I'm trying to think of the last time that we had a series. Um, I guess, obviously that was in 2024. 2025 started off in a little bit of a different way for me, but regardless, I'm happy to be back with all of you. First series of 2025. It's not my first live stream of 2025, but it's my first learning series of 2025. So really glad to be back with all of you. Hope that you're doing well. I'm already seeing people in the chat. Is it this way? I'm already seeing people in the chat. So really happy to see you guys. Go ahead and start filling up my chat. As you can see, I'm picking up already my Instagram and my YouTube followers. So guys, I'm embarrassed to say this, but I had to relearn all of my software this morning. I've been up since like 2 in the morning because I had to relearn all my software and log back into all my accounts. And because, I use various tools, right, to bring this to you guys. I had to update some software because I hadn't updated it in so long. But I hope that I have everything up and running. And, let me know if there's anything that needs fixing. But I'm pretty sure we're back to good as we always have been. But let me know if there's something that's not clear or something I can fix. Let me know, guys. But look at this. Look at this chat. This chat's already filling up. Thank you so much, guys. Yeah, I'm going to go right to the chat. Nirakar says, welcome back, Dennis. Thank you. Thank you so much. Appreciate that, guys. Yeah, guys, I enjoy the streaming. You guys know how much I love that. But 2025 started off a little bit differently. So just had different things, as you guys know, I took a little bit of a break at the beginning of 2025, but so glad to be back with you guys because look, I don't forget things and I don't want to welch on you guys because you guys are important to me. So I know that I've promised you a series on neural networks and I know that we've also talked about doing something with robotics. So Starry Vibes, I see you in the chat already because I know you wanted something on robotics and I got an idea. For something we're going to do around robotics. So I promised you a neural networks and I promised you a robotics series. So we are going to do those, okay? So today is my first Sunday streaming. I'm not sure if I'm going to get back to daily. We could do daily at some point, but right now, let's just start off with Sundays, Let's just start off with Sundays, ease into the year, ease into the series, and we'll see where we end up. But yeah, thank you so much, Nirakar. Casual Economist, our good friend from Minnesota, says, wait, who is this guy? Good to see you, my friend. Hope you're doing well out there. Let us know how everything's doing out there in Minnesota. It must be a beautiful time of the year out there. Michael, our good friend Michael from Lagos, Nigeria, says, happy Sunday, Sir Dennis and everyone. Happy Sunday to you too. My Sunday's off to a good start. I've been up early. Like I said, I've been up since 2 a.m., walked my dog, went out, had a good time this morning, working on the materials. It takes a lot for me to put these things together for you guys, right? So I was working on some materials, working on my business a little bit. Guys, I wanted to share something about my business. Really cool. I'm sharing this as maybe it encourages some of you, but I had not one, but 2 clients in job interviews this week, late in the week. And one of them actually already got a job offer. They're going to be working for a very large company. My other client, they're in advanced interviews later this week, later rounds. But the jobs are out there, guys. The jobs are out there. My first client is going to be going into a very, very high level analytics role at a very, very interesting company. And the other one is also an analytics role in the finance space. So the jobs are out there, guys. So I've been working a lot for my clients, helping them, kind of get ready for those interviews and all that. But Sunday has been going very well. So thank you, Michael. So good to see you. Leo, my good friend Leo says, all right, we're back, Houston. Yeah, we are back. Like I said, guys, we'll start off with Sundays and, maybe we'll go back to dailies. I know a lot of you guys like the dailies. I like them too, but I gotta tell you guys, it's draining to do these not these interviews, but these streams. It's tiring. It's draining. So we'll see. We'll see. Casual Economist says, "Is this AI? Are you kidding me? If I was doing AI, do you think I'd make my AI avatar this fat? Come on. If I do an AI avatar, it'll be like 50 pounds lighter, guys. Come on. You know what? I've investigated those avatar programs, and none of them are really like really blowing me away. Like I spent a lot of time with HeyGen. I have a HeyGen avatar. I didn't really like it. I went to a conference, the Human X conference, and I saw the displays by Synthesia, and they seem a little bit more advanced, and I haven't tried theirs yet. Synthesia is really expensive if you want to do your own personal avatar. So I don't know if I'm going to do that, but I don't know if the AI avatars are there yet. But come on, the course is not AI. I'd make it like slimmer. Come on, guys. Starry Vibes, our good friend says, "Hello, sir. Hope you're doing well. It's been a while. We've truly missed you." Oh, thank you so much. I've missed you guys too. I miss checking in with you guys. You know, I worry about you guys when I hear about different things going on in different parts of the world, because I know that I'm fortunate to have viewers all over the world. But thank you so much. I've missed you guys too. Hope you're doing well out there, Starry Vibes. Hope the school year is still going well for you. Leo says, "This is AI, Dennis." I wish. You know, I was looking at the AI items because it would be easier for me to come up with more material if I ever wanted to do a data science school or some sort of an online school. I would probably use AI tools for that, right? But no, guys, I like giving you guys a genuine connection. You know, I like doing the live streams. I like that. I always envision myself doing live content because I think it's more genuine. I think it's going to be much more in demand in the future. But no, this is not AI, and I try to use AI as little as possible with you guys. You know, if I do an online school, I'm going to have to use AI. But no, this is real. This is the real Dennis, not AI Dennis. Michael said, "Had no idea that we are back. Have to go get my pen and paper." Michael, did you not notice I was gone? I'm not sure if that's a good sign or not. But glad to see you here, Michael. Arcan2 says, "First live, have watched the other series regularly." Oh, thanks so much, Ken. I think it's Can2's, I think is the last name. But thanks so much. Welcome. Yeah, you know, I love doing these series. These series are fun. So yeah, let's get back to it. So, Ken2's, you're welcome to stay on Instagram, but feel free to join us on YouTube if you want to get a little bit of a wider format. Okay, it's up to you. Abiola says, "Hello, Dennis. Nice to be able to make today's session." Well, glad to have you too, Abiola. Your name doesn't sound familiar. It might be your first time. Either way, welcome. Zijan says, "Thanks for this." Hey, you're welcome, Zijan. Glad you're here. Glad to see people on Instagram. Anybody on Instagram is welcome to stay there, or you're also welcome to join us on YouTube. It's up to you. Michael says, "Nice to have you back, Dennis." Yeah, thank you so much, Michael. Good to see you too. Yassine, my good friend Yassine from Morocco says, "Hello, sir. Yassine from Tangier, Morocco." Yassine, so good to see you. Hope you're doing well. I'm assuming that you're still in school, right? I think school is still going on for most people around the world. I know it is for my niece and nephew. Late this week, I was also contacted by somebody who told me that they were accepted to UC Berkeley in the data science program. I think I posted that yesterday morning. So I think the school year is still going on, and also there are the college admissions decisions here in the U.S. are going out around this time of year. So I know it's a busy time for students and all that, but glad to see that you're here, Yassine. Let us know how your studies are going, my friend. Osama, another good friend from Morocco, says, "Hi everyone, sir. It's great to see you again. Hope everything is going well." Yeah, thank you so much, guys. Thank you so much. Really appreciate it. Yeah, everything is going well. Like I told you guys, I took a little bit of a break at the beginning of January, but slowly getting back into content creation, slowly getting back into streaming. So we'll start with Sundays and just see where we end up, right? Starry Vibe says, "Oh, this is awesome. I really appreciate it." Yeah, Starry Vibe. So we're gonna do neural networks, and then I promise that we're gonna do a robotics session. I don't know if I can do a series out of robotics, but I have a really good idea in mind. I have a really good idea in mind that we're gonna do. So it might just be one long Sunday. We'll see. We'll see, Starry Vibes. But we're gonna feel our way along with the neural network series. I think it's gonna be maybe 3-4 Sundays, maybe. And then we'll do the robotics immediately after that. But if you guys have other suggestions you want to see after that, let me know. But I'm pretty solid on ideas for at least the next 5-6 weeks. Alberto, so good to see you. Says, good to see you again, Dennis. Thank you so much. I appreciate it, Alberto. Thank you for the welcome. Leo says, yeah, welcome back, everyone. Leo, I love how you welcome the room. Thanks so much. Appreciate that. Lolman, our good friend Lolman from Nepal says, hello, Dennis. Great to see you after a long time. Hope you're doing good. Yeah, I'm doing really good. Thank you so much. Thank you so much. Yeah, I guess it has been a long time, right? Because I remember I streamed in the first week of January. So I guess that was 3 months ago. Man, so much has happened. So much has happened. But glad to see you here, Lalman. Hope everything's going good in Nepal. Let us know how you're doing out there. I imagine that right now the weather is nice out there, but I've never been there, so. Lanry says, hello and welcome back, Dennis. Hello from Belgium, everyone. Nice. Thank you so much. Lanry, so good to see you. I know that I see your comments on my Instagram when I post it. Thanks so much, my friend. Glad you're here. Hope everything's going well in Belgium. If I remember right, I think you're also a student out there in Belgium. You might correct me if I'm wrong, but hopefully you're doing well out there. Is it Enas or Inas? I think it's Enas, right? Enas says, hello, Dennis. Glad streaming is back again. Yeah, me too. I had forgotten until I just started right now how fun streaming is, because I do find this fun. It's very draining, and I got to prepare a lot of materials ahead of time for the Sunday classes, but it is ultimately fun. So yeah, maybe we'll get back to this a little bit more frequently. Leo says, so good to see old and new faces on this new season. Data Science of Dennis Season 2, just dropping fellas. Just dropping fellas? Help me understand what you mean by the last one, Leo. You lost me in the last one, but yeah. The Season 2, okay. Yeah, sure. We can call this Season 2. I kind of like that. Abiola says, can we do a series on operationalizing MI solutions? Yeah, that might make for a series. We've done little bits of it when we did the end-to-end. But then again, I guess it means what you mean by operationalizing, right? To me, that means, having an API endpoint. But obviously it can go beyond that, right? Yeah, so maybe we can do something on operationalizing it. Maybe. Yeah, if you have other ideas like that, or if you want to tell me more about how you envision that idea, Abiola, let me know. But I'm open to that. Yassine says season 1 was so goated they had to make the second. I hope so. I mean, I'm just trying to give you guys the best content I can, right? The best genuine content that I can. So if you guys find it helpful, that's awesome. Otherwise, I'm just some guy sitting at home talking to himself, right? Okay, so Lanry says, yes, student going until my final year. Nice. Congratulations. It's always good to see, young people advancing. Like I said, it was really cool to get that message from the guy who got into Berkeley. I got another message early in the week of somebody who got their first job. So yeah, it's pretty cool if that helps you guys and keeps you guys going. Denelson says, good morning, everyone. Denelson here from LA. Hope everyone is doing great. Glad to see the streaming is back. Missed these meetings so much. Denelson, thank you so much. Such kind words. And we missed you too, my friend. So hope everything is going well for you out there in LA. I think LA has been pretty calm the last few months. So hope everything is good with you and your family out there. But thanks so much, guys. Wow, all these great welcomes in the chat. Really appreciate all of you. That's pretty cool. Thank you so much. Very humbling. Really, really appreciate that, guys. So glad to see that all of you are around and excited and still want to learn. And like I said, when I hear about all the different things going on in the world, I worry about you guys. So I'm glad that everyone is doing well and happy and just ready to continue data science. And it's also good to see all of you wanting to continue with data science. As I've shared in the past, sometimes, even with coworkers, like, really talented, like, professionals, I'm always hesitant to like teach them data science because I've had many, many people approach me over the years. Oh, Dennis, I want to do what you do. Help me become a data scientist or whatever, right? And people kind of fall away, Not everybody sticks with data science. They either find it's really not for them or they're really not ready to make a move, because people kind of get comfortable in what they're doing, right? So credit to all of you guys for sticking by it and wanting to keep on continuing being a data professional. So good for you guys. Really, you should all be proud of yourselves for that, even though it may not feel like a big deal. It really is, because not everybody sticks with it, right? Not everybody follows through with what they say they're going to do, right? Like anybody can get excited about data science for a week, right? But can you stay after it, after the month 1, after month 2, after month 3, right? So good for you guys. Really glad that all of you are here. Really glad to see that you're, serious students of data science. And I'm glad that we're forming a community in that way, right? So thank you so much, guys. All right. So last call if anybody wants to say hello. Otherwise, I'm ready to switch over to my classroom view where we can start talking about neural networks. Gosh, guys, I'm watching myself over here on my Instagram feed also. Look at this chin. Oh, you guys think this is an AI avatar? Do you think I would give an AI avatar this chin? Come on, guys. I need to cut the carbs again. Ugh. Definitely not AI. This chin proves it. I just say this neck, right? I kept on saying this chin. Lanry says, I have a series title for you, Agents of Insight, AI, and Data Science. Okay, provocative. I want to hear more, which is the good sign of a title, right? You kind of want a title to like draw you in, right? So, okay, Lanry, let me know. So Lanry and Aviola, if you guys want to tell me a little bit more about the series, like what you imagine it, let me know. But they're not bad suggestions, so I'm open to it. Like I said, I'm pretty set for the next 5-6 weeks. But beyond that, if you guys want to send me suggestions, let me know. All right, so I'm still seeing a couple people on Instagram. You're welcome to stay there, or you're welcome to join us on YouTube. And as a matter of fact, let me put that in the chat, guys. Give me just a second. Make sure that the YouTube or the Instagram people know where to find us on YouTube. Okay, cool. Mark says, hello, Dennis. I love your content, man. Thank you so much. I wanted to know if I can ask you advice on my project. Maybe. Put it in the chat. If it's a short question, I'll take a look at it. On Sundays, I don't always take questions because I do want to kind of focus on the neural networks, but feel free to put it in. If I can't help you, maybe somebody else in the chat will, right? Okay, guys. So let's switch over to our familiar classroom view. Can everybody see that okay? It looks like actually I'm blocking myself because of the chat. So give me just a second. That should work. That should give us enough of the chat while also giving us enough screen. Let me know if that doesn't look good on your end, guys. But I had made some adjustments because I was recording other things. But I think this is very similar to our previous view, and it should be big enough for everybody to see. Let me know if that's not the case, okay? Michael says, okay, Rosendo says, thumbs up. Thank you so much, Rosendo. Rosendo, I think you're coming over from Instagram, right? I think you were the previous person on Instagram, so thank you. Michael says, I recently took a course on responsible AI and ethics. May not be a series, but I would love to hear your thoughts on that. Ooh, that could be very interesting. Lots to talk about there, right? And I'm glad you're taking, or I'm glad those types of courses are being taught, Michael. So thank you for that info. Lots to talk about there, right? But yeah, we could do that. We could do something around that. Also, depending on how a couple things work out for me in the next week or so, I might have other series ideas that we can work in, but we'll see what happens there. All right, guys. So neural networks, let's talk about them, right? Here's one thing that I'm going to do a little bit differently for today, because we're kicking off the series today. I think that there's way too many tutorials out there, or way too many approaches, like Coursera courses or whatever, that just jump into, hey, let's program a neural network. And, they get all excited about it and they talk about the frameworks and all that. But what I want to do is I just kind of want to just take a step back. And I want to give us all a meta view into what neural networks are. So as you guys know, I love the participation. So I'm going to be relying on you guys to give me some answers and feedback here. But I expect that we're going to do very, very little coding today. I kind of just want to talk about neural networks at a high level, because I don't think enough people take the time to do that. And I want to do this for two reasons. Well, three, right? Not enough courses do that. But two, I don't think you can really work with neural networks effectively long term unless you take the time to understand them, right? And three, I just think it makes them less intimidating, right? Like, let's take our first poll right now in the chat. I'm going to ask you guys to be honest, all right? Give me a 1 when you hear about working with neural networks. Give me a 1 if you feel intimidated by it, or give me a 0 if you're not intimidated by it. I'm not going to call on anybody, right? But aren't neural networks kind of intimidating, right? Like if you're just starting out, if you're just kind of, working your way through data science, it's kind of intimidating to talk about neural networks, right? It sounds scary, right? Okay, so I'm already seeing some votes, right? Give me a 1 if you find neural networks intimidating, or give me a 0 if you're not intimidated by neural networks, right? I'm already seeing some ones, which I totally get, right? Like I'm admitting to you guys that when I was learning, I thought learning about neural networks was like learning like a whole other thing, right? So I want us to take the time to think about these things, because by doing that, I think we're going to try to take some of that intimidation factor out of it, right? And also, you guys know how big I am about being able to talk to people like the non-math guy, right? And how can you talk to a business stakeholder in a way that they can understand neural networks if you yourself don't understand it in that way, right? Like, you won't be able to do that, right? If your first class on neural networks is, hey, let's talk about PyTorch, and this is what a PyTorch, neural network snippet looks like that doesn't make you an effective talker to business stakeholders, right? So Vidor says sometimes seems like an otherworld thing. Yeah, absolutely. So, okay, guys, so I'm seeing basically a lot of ones in the chat, right? So, okay, so let's agree that they're intimidating. I totally get that. So let's just talk. Let's just take a step back, and we're just going to talk like human beings, right? No math, no crazy nonsense, right? We're not going to, be focused on PyTorch or Keras or anything else. Let's just talk. All right? So, what's a neural network? Give me your answers in the chat. What's a neural network? Let's just start there, right? Super intimidating word. But what is it? A business, you're sitting in a meeting, you're presenting your solution, and one of the business stakeholders says, okay, yeah, you're telling us this great solution, but I don't know what a neural network is. What is that? What are you going to answer? What do you guys think? There's no wrong answers here, guys, right? This is all an exercise in all of us working things out to kind of take that intimidation factor out of it, right? So that's all we're doing. There's no wrong answers. I'm not going to call anybody. You're going to be okay. Just what's a neural network? Okay, so Enos is saying, let me know if it's Enos or Inos. I'm going to go with Enos. Connected neurons, maybe? Okay. Alberto says, a network of neurons to make a prediction. Okay. Anybody else? I'm going to give you guys another minute here. Rosendo says, shows the probability of how variables are connected. Okay. Lanry says, a computer system that tries to learn like a human brain. Okay, Lanry. I think I'll give you guys a hint. Lanry is headed in the direction of an answer that I would give. Vitor says, I think in some attempts to imitate a human being neural network with neurons and stuff. Okay, Vitor. Vitor and Lanry are on the right track. Not that the other answers are wrong, by the way. I'm just trying to help you guys understand how I would present this to like a business stakeholder, right? So I believe I left it with Kago. Kago, am I saying that right? Kago says a layered approach to predict the output where the weights are updated at each layer. Okay. Yassine says it's like a little kid learning from the things we show. Okay, nice. I love Yassine's usage of like non-technical terms, right? I like that. Okay, Enos. Okay, thank you so much, Enos. Starry Vibe says learn patterns from data inspired by how the human brain processes information. All right, cool. All very good answers. Yeah. So I think all of you guys are on the right track, right? So here's what I'm going to propose. And this is what I've used in actual like business meetings, right? And that's just to say a neural network is a mathematical representation of how the human brain works. That's it. This is a definition that I've used with, high-level executives, and they understand it, right? So you don't have to quite get into, the neurons and all that aspect of it, but it's just a mathematical way to simulate how the brain works. That's all it is. Denelson says, a system of linear algebra algorithms that trigger each other, mimicking a human's neural network of exploring and learning and correcting itself. Okay, cool. Thank you so much for that, Denelson. So this is the kind of definition, what you're seeing up on the screen, that I would give to a business stakeholder, right? Because again, nobody is wrong in the chat, but we're going to keep things simple. We're going to keep things simple and not intimidating. Because if you're intimidated by it, then your stakeholders are also going to be intimidated by it, right? And you'll never be able to successfully explain it in a confident way, right? But that's all a neural network is, right? Once you understand that really all you're doing is math to simulate the brain, to me, it becomes a lot less intimidating. But of course, we're going to take it steps further to keep on like deconstructing it and learning more about it, right? Okay, so if we're talking about the human brain, then we kind of have to also start here, right? Like, let's look at what this is. So this here is a nerve in our bodies, right? And we have millions and millions of these nerves throughout our bodies. And you can see that there's a direction being indicated, right? The signal, the electrical pulse, right? The electrical signal goes from left to right in this scenario. So over here on these dendrites, you have a bunch of different possible inputs, right? Because inputs can come from any number of places in your body. Based on that input or the lack of an input, there is a firing of the electrical impulse, right? Along the body or the axon of the cell. And then it goes on to these terminals to do other things, right? In most cases, they're connected to other cells, right? Because these millions and millions of cells are interconnected all with each other, right? So if I'm sitting here and my brain is telling my hand to move, right? Then my brain is firing all throughout down my brain, my neck, down my arm and up my hand and causing it to move, right? And it's causing my other hand to not move, right? So there's firing going on in these nodes or these cells, but there's no firing going on over on this side, right? Because I'm not asking this hand to move, I'm asking this hand to move. But the point being is that there is like a flow or an order to that, right? Where the signal to want to do something starts in my brain. An electrical impulse is initiated and then run through the relevant cells to say, oh, okay, I need to move the muscles in this shoulder, but this shoulder over here stays still, right? So there's electrical impulses and connections being made on this side of my body, but not on this side because that's not where the inputs are telling it to go, right? So that's basically all that is. We are going to take this cell and that process that I just explained to you, and we're going to represent that in a mathematical way. We're going to have mathematical representations of this nerve, and we're going to decide which nerves should move and which nerves shouldn't move, right? Which ones should fire and which ones shouldn't fire, right? Everybody with me on that? So Abiola says a neural network is a model that mimics how the brain neurons work. Yeah, sure. Yeah, very much like that. Very much like that. All right. So I'm going to guess that most of you have seen something similar to the chart that's over here on the right-hand side, right? This is our basic representation of what a neural network is from like a data science side, right? A neural network, as some of you pointed out, is made up of a series of layers. But again, those layers is just a continued representation of what we talked about, right? Because just like in the human body where we have millions and millions of cells, we can have large neural networks that have a lot of different nodes. And you can think of those nodes, each node as being very similar to the cell that we saw earlier, right? So this cell, if you're bought into this idea, this cell is represented by a node. And you can have multiple inputs, right? Because there's multiple things that can cause me to move my arm or have a need to move my arm. There's different layers and nodes because there's different cells that go into moving my arm, right? I have to have some nodes that fire in my shoulder, some in my elbow, some in my wrist if I want to move my wrist at the same time, right? So there's multiple layers and multiple cells that can function, that can fire at any given time, right? And then there's multiple outputs that can happen, right? I can have my hand go up, have it go down, have it go to the side, whatever you need, right? So, but that's really all we're doing. We're just creating a way that simulates the manner in which a human brain works. So Leo says, it's really important to stick with these details of how data is transformed to information. Love how Dennis approached an intuitive way. I appreciate that, Leo. Thank you. Yeah, guys. I mean, I love Leo's point here, right? Because you guys know that I'm not just trying to teach you data science just for the sake of it, just to say you did it or just to pass some interview. I want you to think about this from like, how am I actually going to use this in the real world, right? And being able to explain this to other people is super critical in the real world, right? Because otherwise you just become a person nobody wants to talk to because they don't understand the word you're saying, right? So thank you for that, Leo. Appreciate you saying that. All right. So we're going to have our input layers, we're going to have our hidden layers, and we're going to have our output layers. And each one of those is basically just a series of cells very similar to this, right? You can have any number of nodes and you can have any number of layers. That's one of the beauties and also potentially one of the downsides of neural networks, that you can construct neural networks in whichever way you want. They're much more flexible than most other models, right? Most other models are fairly prescriptive on what they have to look like. You're really just kind of changing the weights, right? In many ways. But neural networks can be designed in however way you want them to. Nobody can tell you, like, if you say, well, I want my next neural network to have 20 layers, no one can really give you like a rational reason why you shouldn't do that. Your neural network can be whatever you want. You can have however many layers and nodes that you want. There's very, very few hard and fast rules to what you can do with them. So it can be a little bit of a challenge because you don't know what the final form of your neural network is going to look like. You have to run the experiments, right? And that's okay. But you have a lot less guidance than you would in most other models. There's a lot more to choose from when you compare neural networks to other models. But the bottom line I'm trying to impress upon you is a network can be anything you want it to be. There's no real prescription for it. And I think that's a good thing, right? All right. I want to also kind of show you this chart because I don't want you to think that you can just have one layer in your neural network. I think that's a common mistake that a lot of people make, where I see people, give me these very small neural networks, but that's because that's all they've ever really seen, right? I mean, unless you've done a lot of work with other networks that are out there, you've never really seen something with 15 layers, 20 layers, 30 layers, something like that, right? But just keep in mind that you can do whatever you want. You can have as many input layers, as many input nodes. You can only have one input layer. You can have as many hidden layers as you want, and really just design it any way you want. Okay? What you should also be aware of, though, is that if you look at these arrows are not randomly drawn. You have to look closely to realize that every single node is connected to everybody else. So from this node here, you're going to find 4 connections because of the 4 hidden nodes. This one also has 4 arrows, and this one also has 4 arrows. They kind of get lost in the mix, because it's just the way the graphic is laid out. But all nodes are connected to each other in some way. Again, similar to your body, right? There's you can feel things throughout your body, but that's only possible because essentially all nodes are connected to each other. You only have one central nervous system that does all those electrical impulses and connections throughout your body, right? Us as humans have a lot of those electrical things coursing through our body, but it's all just one single central nervous system, right? So everything is connected to each other. That's the network part of it, right? Because somebody's going to ask you, like, what do you mean there's a network? Well, that's the network. All of the nodes are connected to each other. It's possible for you to be able to trace back through and say, well, how is this node connected to that? Oh, because of this path here, right? That's the network side of it. So the question is, how do those nodes all communicate with each other? Right? I just finished telling you that you can have as many nodes as you want. You can have as many layers as you want. But how do they communicate with each other? Now, in the human body, they communicate with each other via electricity, right? And what and how is decided the things that need to fire? Well, that's kind of like, one of the wonders of the human body, right? Like that's like your human consciousness decides that, right? But how does that happen in a neural network? So give me your thoughts in the chat, guys. If we just said that all the nodes are connected, then how do they communicate with each other? If we said that this is a mathematical representation of how the brain works, how do we represent that in a neural network? Like, how do we transfer that over in a neural network? Let me know. Start putting your answers in the chat, guys. Rosendu says, it looks like a cross join in SQL. Yeah, sure, absolutely, right? It does have a little bit of that relationship feeling in SQL, right? The difference is that in a neural network, there's kind of a many-to-many relationship, right? So one node can have many connections, and one node can be connected back by many nodes, right? Did I say that right? Yeah. Yeah, one node can have many outgoing connections, but it can also have many incoming connections, right? But yeah, Rosendo, you're on the right track there. You're on the right track. So let's think about those connections, though, right? If there is all this network connectivity, right? That's the network part of the name. How are they connecting? Like, how are they communicating? Rosendo says by desired outcome. Yeah. Rosendo, take that one step further. Oh, Leo says, oh, thank you, Leo. I think I missed this question. Thank you. So Vidor says, but then the choice of neural numbers is just it's initially just a shot. Vitor, not always, and we're gonna get to that. Okay, we're gonna get to that. Is it initially just a shot? It can be, but there is some guidance available, and we'll talk about that. Okay, we're gonna talk about that. Vitor, if I don't give you a satisfactory answer, let me know, because you're asking an important question. Okay, so Yassine says using the weights. Okay. Yassine says represented as matrices. Okay, Yassine's on the right track here, guys. So how do they communicate with each other? These nodes have to talk to each other and decide whether to fire or not, right? Like how does your neural network decide like what path it's going to take to get to that output layer, right? Okay. So Bimala says Relu helps to fire the neutrons or decides to not fire. Okay. Osama says via weighted connections. Okay. Yeah. I love how you guys are being creative in the answers. But sometimes it helps to be a little bit more formal, right? Because giving just a little bit of formality helps you also establish yourself as an expert, right? And Yassine, I just saw you put in the right answer. Well, I shouldn't say the right answer, but the answer that I had in mind. So Yassine is right. It's using activation function. That is what we should be looking at, right? Alberto says by mathematical representation, function, weights, maybe. Yeah, so you guys are on the right track, right? You're on the right track in the sense that well, wait a minute. I know that I have different inputs, and I know I'm going to assign weights to those inputs. That's every algorithm out there, right? That's y equals mx plus b, right? So you guys are on the right track. All of you gave great answers. But Yassine here has it. Yassine has it. Using activation functions, and that's really what I'm looking for there, right? They communicate or don't, right? Because there are situations where you're going to have nodes that don't do anything with activation functions. Nodes essentially exist to compute activation functions. That's it. That's what a node does. That's the whole purpose of a node. That's how we are representing the human consciousness of making decisions by having activation functions that take in a weight, right? Taking a weight and a factor, one of your inputs. It does some processing, whatever the algorithm is for that activation function, and moves on. It sends a value out, right? And that's the firing or not firing of of the neural network, right? So Bimala mentioned ReLU, right? ReLU helps to fire the neuron or decides to not fire. Are there other activation functions? Put it in the chat. Give me some other activation functions. Because Bimala is correct. The ReLU is one of the activation functions. But what else is there? Rosendo says, what's an activation function? Yeah, Rosendo, good question. So an activation function is basically a math formula. That's all it is. It's a math formula that usually, in most cases, takes in a factor, a value of some kind, and it takes in some sort of weight that in most cases is previously assigned from a previous node or a previous layer. And then this layer says, okay, I now have this function, I now have this factor, and I now have this weight. Those are the two parts that are then given to your activation function. And your activation function takes that, it acts as a math formula and does its computations, and it basically says yes or no at the end. I'm simplifying that, right? It's not always a binary output, but that's all it does. It basically takes in a factor and a weight. It does its own computation according to what kind of activation function it is, because there are many activation functions, and spits out an answer. But that's all it is, okay? Okay, so Kago is coming up with sigmoid, Yassine sigmoid, yep, softmax from Landry, softmax again, yep, Osama says ReLU, yeah. So let me ask you guys something. Can you come up with your own activation function? Do you have to stick with these activation functions? Give me a yes or no on that. Are you allowed to have your own custom activation functions? Okay, Yabadabadoo, great name, by the way. I love the name. Over on Instagram says, like independent variables and their coefficients in regression. Yes. Yes, I love it. I love the way you're putting this. Yes, absolutely. I did mention y equals mx plus b, right? Which is your standard regression. And the mx part of that is exactly that, right? The m is the weight, the x is the factor, right? The feature. So yes. And perhaps I shouldn't overlook that so quickly, because that helps you. I think that also helps to take the intimidation factor out of neural networks. When you start to realize that, wait a minute, all I'm doing is taking a feature and a value, and all I'm doing is a feature and some weight that I want to attach to it. That's it. Like, that's all we're doing. We're doing it a lot, and there's a lot of nodes and there's a lot of layers, but that's all we're doing. Y equals mx plus b. That's all you're doing. So Yabadabadoo, thank you so much for bringing that up. Yes, you are absolutely on the right track when you think about that. What is the factor that you want me to consider, and what weight do you want me to assign to it? That's it. That when you see these like complicated charts and these nodes, that's all you're doing. You're just passing on those weights and features, right? Each one of these arrows, that's like the little transport packet, right? Here's the feature, here's the weight, go do your own calculation. That calculation finishes, it gives it a new weight, here's the factor, here's the weight, go do your own. That's all you're doing. Because in turn, that's what your body's doing, right? If my brain wants to move my hand up and down, the cell here is telling the same thing to the cell here. That's the cell here. Move your hand up and down. It's the same message, right? It's just different ways of doing it. So that's all you're doing, right? You're just passing along the same message. So Yabadabadoo, thanks so much for that. Yeah. Okay, yep. So everybody is saying yes to the custom activation functions. Here's the thing, guys. The reason I'm asking about the custom activation functions is because I also want to put that as a little bit of a warning. I think sometimes people get too caught up in the need for custom activation functions. Unless you're doing something truly, truly special, you probably are overusing any custom functions that you have, right? Because there's plenty of activation functions to choose from. There's really no lack of them, right? So keep that in mind before you go down a road or before you come across a tutorial or a snippet or something that talks about, using custom activation functions. Because with all the neural networks that I've worked with and whatnot, very, very rarely would you ever need some sort of custom function. But the reason I ask that is just to kind of illustrate that the activation functions have a fancy name and all that, but it's just a math formula. You can do whatever you want. It's just a weight and a feature, and you can just sit there and say, well, if the weight is more than 0.5, I want to say yes, and if it's less than 0.5, I want to say no. It can be that simple, right? It can be whatever you want it to be. All right. Leo says, keywords so far, if you want to study independently after the class, nodes, layers, weights, and activation functions. Thank you so much, Leo. I appreciate that. Kago says, I should actually be able to justify why I am using a certain activation function. Sure. Kago, I don't know if that's a question or whatnot, but is that a question or a statement? Landry says it's just a mathematical rule you define that transforms a number. Yeah, absolutely, Landry. Yeah. Thank you for posting it, Landry. Maybe I should have read your comment, but similar to what I just said, right? It can be whatever you want. You can define the function yourself. But again, you'd have to be doing something really, really special to not use the ones that are already out there. Leo says, agree, Kago, certain models are going to require different functions. Sure. So Kago says it was a statement. I should actually be able to justify why I'm using a certain activation function. Sure, Kago, but also realize that some of those activation functions are going to be defined for you, right? It depends on what you're trying to solve. Are you trying to solve a binary problem? That's one kind of activation function, right? Are you trying to solve an NLP problem? There's some activation functions that lend themselves better to that, right? So you will be able to justify it in many cases just by what you're trying to solve, okay? So keep that in mind. We'll definitely be exploring that later weeks in this series. I don't think we'll be exploring that too heavily today, but, just keep that in mind going forward. But you're on the right track. Thank you for that, Kago. All right, guys. So we just agreed that there can be a lot of nodes, that there can be a lot of layers, and all those nodes and all those layers are interconnected in some way. That's the network side of neural networks, right? Does that come at a cost? What are some of the problems that you guys can anticipate with that? Does that come at a cost? Are there any pitfalls there we should think about? What do you guys think? Let me know in the chat. What do you guys think? Everything's connected. It can be whatever we want it to be. It can be as big or as small as you want it to be. And we know that there's a lot of math going on in each one of these nodes, right? Because each one of these nodes, because we're basically saying that each one of these nodes has their own little computation going on, right? What do you guys think? Does that complexity come at a cost? Okay, so Yassine says computation. Tell me more, Yassine. Kago says, if it's too big, the model might struggle to generalize the unseen data. Overfitting. Okay. Vidor says, basically cost time. All right. Osama says GPU. But why, Osama? You're giving me a conclusion, and I don't disagree with your conclusion, but why? Why GPU? Bimala, nice. Interpretability, yeah. Yeah, I mean, does this sound very interpretable to you guys? If I'm telling you that I have 30 layers and 100 nodes per layer, and I'm doing mathematical computations at each one of those, does that sound very explainable? Probably not, right? So Bimala is hitting on a very important point. Right? Explainability in neural networks isn't great. I know. There's been tools that have been developed since then. They have become more explainable. I get it. But, we're building from the ground up here, right? And in traditional, in traditional neural network education or understanding, neural networks don't have a great reputation for interpretability. So that's one of the complexities, right? It's really math based. So it's just not very friendly to be able to tell business people, hey, this is our conclusion and we think it's because of X, Y, and Z that you're doing. Neural networks are not great for that. Rosendo says the more pathways, the longer it takes to get to an outcome. Yeah, that's exactly right, Rosendo. That's exactly right. Yassine says it requires parallel calculations. Doesn't require it, Yassine. It's highly beneficial if you can do them in parallel, right? And that's one of the reasons why GPU is popular. But it doesn't require it. It just makes it more convenient, right? So keep that in mind too, guys. Landry says, at Leo, a math rule that changes a number, the neuron's output, before sending it to the next layer. Yeah, Landry. Landry, you're getting pretty close to another thought I had in mind. But we'll keep going here. Osama says, huge number of mathematical operations, especially matrix multiplications. Yeah, absolutely, Osama. And that's definitely one of the reasons why GPU is beneficial for neural networks. So guys, I want you to also pay attention to Osama's answer, because Osama is also bringing up something really important. He says, especially matrix multiplications. And he's right. A lot of these things are handled as matrix computations and matrix multiplication. And we'll get to that in later weeks, right? But this does set itself up nicely for matrix multiplication. But the key word in there isn't matrix, it's multiplication. What do you guys think? Does that bring additional complexities? What do you think? What other complexities could there be because of multiplications? And this one's important, guys, because when you're working in business, right? People are going to ask you, okay, Yassine, I'm bought into your solution. Are there any risks here with your solution? And these are some of the risks, right? I'm kind of asking you. I say complexity, but I'm really asking you, what are the risks here, right? These neural networks sound great. You're telling me I can represent a brain? That's awesome. But are there any risks? Like, should I know about any downsides? Everything good has downsides, right? More layers and nodes equals more calculations, more time and money. Yep, Landry is absolutely right. Neural networks are usually not very fast to train, right? And you see that now in generative AI, right? Because generative AI, we'll get to this later, is based on neural networks. I mean, Sam Altman has said that in interviews, right? That they have models that are taking months to train, right? They are GPU and they are time constrained. That they know that they can't release models for months from now, that they presume are going to be much more powerful, but literally take weeks and weeks to process, right? Even with their resources and their multiple data centers and distributed computing and all that, right? Some models just take a really long time, right? Yes. Yes. Well, let me come back to you. See, Leo says, well, sometimes I don't trust my own brain, so it's understandable asking this question. Yeah, absolutely, Leo. And you're going to be asked this question, guys, right? A smart a smart boss or one of your smart leaders isn't just going to say, okay, great. I don't want to hear anything else. Just go ahead and go for it. They're going to want to hear the downsides, right? And honestly, if you want to be a responsible data scientist, you also want to be proactive about presenting the downsides, right? So yeah, so Yassine has hit the answer I had in mind. Yassine says vanishing / exploding gradients. Yeah. So you should know that in neural networks there's something known as the vanishing gradient problem, right? If going with Leo's previous theme, if you want to Google something, Google the vanishing gradient problem. What happens when you multiply a number times a number, guys? And more specifically, what happens when you multiply a decimal times a decimal? Because most weights and stuff, we're talking about decimal values, right? We're usually talking about whole number values. You're usually talking about decimal values, right? What happens when you multiply a decimal times a decimal? So put your answer in the chat. What happens when you multiply a decimal times a decimal? Rosendo has the right answer right off the bat. It gets closer to 0. That's exactly right. A decimal times a decimal results in a smaller number, right? And that's exactly the vanishing gradient problem. Or the exploding gradient problem, as Yassine put it, right? So going back to our charts, if you take 0.5 times 0.5 here, okay, and now you're taking 0.25 times 0.25 here, okay, and now you're taking that number and that number. Next thing you know, by the time you get to your 10th layer, you've got zeros. And if you're doing that for all of your nodes across multiple layers, you basically have nothing, right? So that's known as the vanishing gradient problem. And that's something that you absolutely need to be aware of when working with neural networks. Because all of those activation functions are great until you realize that, wait a minute, all I'm doing is moving decimals around. And if I keep on multiplying those, I eventually get nothing. Right? Or, it's always going to be some value, but it'll be some ridiculously small value that's approaching 0. Right? So we're going to talk about different ways to battle that. But I thought I'd include it here in the first one because this is one of my interview questions. I think this is a fairly common question that you would come across in an interview that's asking you about neural networks, which is basically the same most like data scientist interviews, right? It'd be really hard for you to get through a data science interview hiring cycle and not ask about neural networks, right? But that's something you need to be aware of from the very beginning. Neural networks sound awesome on paper, but the reality is that they do have some downsides. And that's one of them. That if you don't track it closely, you can get to a situation where you basically end up with 0 on the back end. Leo says, that's a great question. Thank you, Leo. Kago says, so does this mean a network with fewer layers is basically better than a deep network? Not always, Kago. Not always. Because depending on the problem, you're going to need a deep network. And there's ways for you as a data scientist to combat the vanishing gradient problem. I won't say some of those today because we can kind of leave that as a little bit of a homework. Like I said, if you guys want to go out and Google the vanishing gradient problem, and maybe you'll come across some of those answers. So yeah, Kago, you shouldn't take it to mean that. you should just take it to mean that it's something you need to be aware of and you need to be kind of vigilant about. Okay. Landry says complex models can memorize the training data instead of learning patterns, which is another issue. Sure. Sure. Yeah, I mean, all models can have that issue, right? In the sense that it could be like an overfitting issue by, um, I want to say like by mistake or like by casual usage, right? But yes, Landry's right that neural networks can be overfit in a very significant way. It's a lot easier to do that than you would think it is, right? All right. So I think we've covered some of that complexity. And again, these are all things for you to think about because if you want to be responsible and present a balanced view of your work, you would always bring up the complexities, or you're going to be asked these things, right? Before somebody gives you a green light, before they fund your project, before they give you the budget, they're going to want to know the risks, right? So we ourselves should be aware of the risks, right? Okay, so let's talk about this. What are the requirements of an input layer? Right, let's keep going. Let's keep going with the with kind of like the risks and complexities, right? So in the chat, let me know what are the requirements of an input layer. Anybody want to just kind of list off a couple things? Let me know. Also, what is the maximum value of input layers that we can have? You guys, if you guys want another question, try that one. Leo says, if you're interested in going deeper and by in between classes, make your own neural network like Tariq Rashid. It's great. Yeah, guys. And I recommend it at the end of this deck, Leo, but thank you for the reminder. Must have a factor weight. Max value is 1. Okay. Rosendo's on the right track there. Landry says correct number of inputs. Yeah, Landry. So what is the maximum number of inputs we can have in our input layer? Yassine says to have as many nodes as features. Okay. Yassine, can you think of any situations where you wouldn't know the number of features? Because your statement presumes that you know that ahead of time, right? Starry Vibe says input should match the shape of the data. Okay, but Starry Vibes, what if you don't know the shape? Yassine says yes. Okay. Yassine says NLP. That's exactly right, guys. You don't always know how many inputs you're going to have, right? You don't. So, kind of by proxy, you can draw the conclusion that there are no rules to how many input how many nodes you can have in your input layer, right? The only thing you know is you can only have one input layer. But nobody can tell you, oh, you can only have 100 max, or you have to have a minimum of 5. You don't know. And as Yassine correctly points out, NLP is a situation where you don't always know the number of features. So Starry Vibes, I'm sure you would have gotten to the same answer, but same question is what I would have told you, right? What if you can't match the shape of your data? There's plenty of situations where that's going to happen, right? Okay, so Osama, I love your comment. Osama says neural networks can't process text or images directly. Okay, so Osama, you took the words out of my mouth because I want to build on what Yassine said about NLP. Because guys, we just said how neural networks are a mathematical representation. But what if you're dealing with non-math data? NLP is not math data, right? So what then? What are you going to do in that situation, guys? Text is not mathematical data. You can't assign a weight to the word dog. Right? They literally don't compute together, right? So Osama and Yassine, let's build on that. Rosendo, when we talk about NLP, we're referring to natural language processing. So basically, we're referring to working with text data. Okay. Alberto says numerical input in assigned weights. Yeah, but Alberto, but not everything's a number. The input I have is my cat is white. How is that? That's not a numerical input, right? The sentence "my cat is white." What am I going to do with that? Suborno, welcome. Suborno says transferring it into numerical data based on its color gradient if it's an image. Okay. Leo says tokenization. Yeah. Okay. Both of you guys are on the right track. Leo's on the right track for NLP, and Suborno's on the right track for computer vision, image processing, however you want to refer to it. Right? Chet Jones says binary. Help me understand that, Chet. Because in NLP, you'd have a hard time using binary inputs, right? Like almost impossible, right? But Leo is on the right track with tokenization, right? This is another question I ask in my interviews, by the way. You would find this in my interview series on Instagram. What's tokenization? What's the role of tokenization in NLP? Manoj, so good to see you, Manoj. How are you, my friend? Manoj says, agree with Leo. Yeah, Manoj, you and Leo are correct, right? So for those of you guys that don't know, write this down. If you're new to NLP, right? Write this down. Because I asked this on interviews, and I've seen other people ask this. What is tokenization? Tokenization is the process of taking words and converting them to a numeric value that can then be understood by models, right? Because you can't put in the word dog into a model that we just agreed is mathematical representation of the brain. So you have to go through a tokenization step to take the word dog, assign it a numerical value, and then you put that into your model. Right? That's really important. And what we're really talking about is we're talking about data pre-processing. Not cleaning, but data pre-processing. Where sometimes, even after cleaning and all that preparation, you have to work with your data to get it ready for neural networks. So who was it? Suborno. So Suborno is talking about the same thing. Except in image processing, you don't need to do that, right? Because image processing does have numerical values, but in most cases, it's going to have more than one numerical value per pixel, right? Each pixel, in most cases, has an RGB value. And an RGB value is composed of 3 numbers. Or sometimes 4, right? If it's RGBA, I think it is, right? But the whole point is that you have to go through that pre-processing in order to be able to use it in neural networks. Because again, you can't multiply the word dog by a value, by a numerical factor, like, or a numerical weight, right? Yabadabadoo says like dummy variables for categorical variables. Yes. Yabadabadoo, that's not a bad parallel, except that you can have so many more of them, right? Because, like, for example, tokenization involves using what's known as a dictionary in NLP. And a dictionary would kind of be like the same lookup as dummy variables, except there's a lot of them, right? In the English language, it's accepted that there's about 20,000 words that are commonly used. So that's about the size of most dictionaries you're going to find out there, right? 20,000, 30,000 words, something like this. So yes, you're on the right track, but it's just a lot more than what you would use in any sort of categorical variable situation. Okay. Rosendo says, learn tokenization in my current class, but makes a lot of sense talking it out. I appreciate that, Rosendo. Yeah, this is why I do these things, right? Because nobody else does this, right? Every neural network tutorial you're gonna find on YouTube starts with, so open up your Python editor and let's talk about PyTorch. Well, that's stupid, right? Because that's not teaching you neural networks, right? So, that's kind of why I want to do this in this session today. We're just talking things out, guys. We're just talking things out, right? And we're taking some of that mystery out too. Okay. But thank you for that feedback, Rosenda. I appreciate it. Leo says, don't keep these things with yourself. Yeah, absolutely. Landry says, so set text to tokens and tokens to numbers. Yes. The tokens essentially are your numbers. Right, Landry? But then it gets a little bit more complex than that. And I don't mean this to be an NLP discussion, right? And so I'm going to give you a little bit of what I mean by how it gets a little more complex than that. And then we'll come back to some we'll go deeper in future discussions. But let's come back to the comments by Starry Vibes and Yassine earlier, right? What happens if we decide to do an NLP model? And let's just take this as an example where we're going to have 5 inputs into our model. So we just discovered tokenization, as Leo correctly pointed out. And let's say we've tokenized our dictionary. So now we can take a sentence like, my cat is white and sick. And we can tokenize that, and we can put it into an input layer here. And we have this model with 5 different inputs. But what happens when now you have this model with 5 inputs, but you have a word that has less than 5 words? Like, my dog is white. That's only 4 words, but we have 5 inputs. What do you think about that? What are you guys going to do then? I mean, you can't have a model you can't develop a separate model for separate words, right? Like, you can't say, oh, well, for this model, I'm going to develop this whole separate model for just 3 words, and then I'm going to have this other model for 10 words, and I'm going to have another model for blah, blah, right? That doesn't make sense. Right? What are you guys going to do in that situation? But, while you guys are thinking about that, Manoj, thank you so much. Really good to see you, my friend. I know you've been a big supporter. Guys, if you see an icon next to Manoj's name, that means that he is a paid member of the channel on YouTube. Really appreciate support by people like him. I believe it's $2.99 USD a month. It helps me out. So if you want to buy a membership, I sincerely appreciate that. So something for you to consider. But Manoj, thank you so much for your support. Really glad to see you, my friend. And we're back streaming. We're gonna be doing this every Sunday now. But what do you guys think? What's gonna happen when you have a model that takes in 20 words as inputs, but your sentence only has 5 words? What are you gonna do? Nobody in the chat so far? What are you going to do? Think about everything we've talked about, right? Yassine says we need different architecture. Yassine, I love you, my friend. You know that, but no. No, we can't do that, right? We can't have a different neural network just because there's different letters or different words, right? Manoj says, glad that you are back, Go. I appreciate that. Thank you so much, guys. You know, I'm feeling a lot of love today. You guys are spoiling me. I sincerely appreciate that, guys. It's been a nice little welcome. I mean, obviously I was nervous because, it takes a lot for me to put these things together. And I don't know if you guys are going to like this. I'm just talking to myself, but really appreciate that. Thank you for the welcome, Manoj. Okay, so Vitor says, repeat the question, please. Okay, so Vitor, I'm proposing that we've built the neural network that you see here. And this neural network is designed for 5 inputs, which could be like 5 words, right? But what happens if you have a sentence that only has 3 words? What are you going to do then? Are you going to have a different model just for 3 words? But then you'd have to have a model for 10 words and 20 words, right? Yassine says, I meant neural network architecture like RNN. No, Yassine, because you'd still have the same problem on the input layer no matter what you're doing, right? No matter what type of neural network you build, you'd still have the problem on the input layers. Okay, so Rosendo says turn off some networks. I think you meant to say nodes, Rosendo. Turn off some of the nodes. Because it's 5 nodes, but you only need 3 of them, right? So Rosendo's on the right track, and then Landry gives us the right answer. The answer is called padding. And padding is an NLP process where you can basically take your text, represent it into tokens. So now you got your text that's represented as digits, right? Because each token corresponds to a digit. And if that number of tokens is shorter than your input layer, you pad it. And we just said that we're multiplying, right? So you turn off the nodes by setting it to 0. Yeah, so Landry is exactly right. It's padded with 0, so the shape matches. Yeah, that's exactly right. And that comes back to Rosendo's answer. We are effectively shutting off those nodes by setting it to 0. Right? That padding nullifies those nodes, and you can essentially turn off that section from your calculations. Now, again, my purpose in me telling you that is not to have this deep NLP discussion. My purpose for you is to help you realize that neural networks have those little extra pre-processing steps that are super important. So if you want to become an expert with neural networks or with NLP or with CV, you're going to have to know all those tricks of the trade that correspond just to that. Right? So keep that in mind, that neural networks do require pre-processing. So let's build on that. If I'm telling you that it requires pre-processing while we're building this neural network and we're still running because we haven't run any tests at this point, right? We're still building our neural network, but I'm telling you about this pre-processing we need to do. What happens when you go to make a prediction? What happens when you actually have a built neural network and you want to make a prediction? Do you need pre-processing then too? Give me a 1 in the chat if you think you do, or give me a 0 if you think you don't need pre-processing. Give me a 1. Now remember, we're talking at prediction time, at runtime, right? Give me a 1 if you think we still need pre-processing, or give me a 0 if we don't need pre-processing. Put it in the chat, guys. What do you guys think? All right, we got a few ones coming up. Yeah, that's exactly right. So keep that in mind, because that's also unique to neural networks. Not every algorithm out there requires pre-processing. but neural networks do. So now take that a step further. We talked about tokenization. I mentioned dictionaries. You might be applying different transforms to like your image data, the way you're handling the RGB values. It's super, super important to keep version control on those items. Because let's say during your training, you use one tokenization method, but on your runtime and your prediction side, you're using a different tokenization method. Are good things going to happen or bad things going to happen? If you're not using consistent dictionaries and consistent tokenization methods, are good things going to happen or bad things going to happen? Like, obviously, bad things, right? I've seen teams go wrong here where you get things lost in the mix, right? There's not enough communication among teams, or you lose, version control or whatever the case may be. Really, really bad things are going to happen in that scenario, right? So you have to be consistent on the pre-processing you do for training and what you do at runtime. Super, super important, guys. Rosenda says pre-processing in this context where you refer to tokenizing your data. Yeah, for NLP, yes, Rosenda. I'm talking about things like that. There's more to it than that, right? Because NLP can have multiple pre-processing steps. But yes, for the purposes of our discussion today, I'm referring to things like that. So if you're tokenizing one way in training and another in production or runtime, it's going to be a bad day. It's going to be a bad day. Leo says, that's funny. Yeah, but I've seen it happen, Leo. It happens. So I think I've made my point there. But my point to you there is, think about that input layer because it's unique to neural networks that you might not have at other ones. Because think about this, guys. I know some of you have been with me from these series from the beginning. Is like when we talked about regression. In regression, you don't have to worry about that, right? Regression, you kind of just like build the model and you're done. But in neural networks, it's kind of unique that you have to do that. Okay, so what are the requirements of a hidden layer? Let's move on. Let's move beyond the input, right? What do you think about the hidden layers? Give me some thoughts in the chat. What are the requirements there? Landry says, my teacher said pre-processing is like brushing your data's teeth before coming to his. That's funny. That's funny. I think he's trying to send a message to the class there, Landry. That's funny. Okay, but let's leave the inputs for now. What about the hidden layers? Hi, Dennis. Alicia from Phoenix. Great topic. Thank you. Alicia, so good to see you. Glad you're here. Hope you're doing well on this Sunday. Thank you so much, my friend. So, Alicia, we're talking about neural networks. Feel free to share your thoughts. But what are the requirements of a hidden layer? Let me know in the chat, guys. Obviously, the question's open to everyone. What do you guys think? What are the requirements of a hidden layer? And then if you want to think ahead, you can probably guess that I'm going to ask you what are the requirements of an output layer, right? But what are the rules around hidden layers? What do you guys think? Rosendo says should not be 0. Yeah, Rosendo. That's a good one, right? You have to have at least one hidden layer, right? You can't go from your input layer to your output layer. So yeah, I'm on board with that. What else, guys? Go ahead and put them in the chat. What else is there? Anybody else? Last call. What are the requirements of a hidden layer? Leo says, let's think intuitively. Osama says regularization. Lanry says number of neurons, activation function. Rosenda says Rosenda says I was referring to the weight can't be zero. Rosendo, but you were right the first time. Don't correct yourself if you were right the first time. You should have said, "Yup, that's what I meant." The weight can't be zero. Okay. Starry Vibe says layer type choose based on the task. Yep. Well, look, guys, the fact that I thought all of you were quiet was kind of like the right answer by proxy, right? Because the answer is that there are no rules. I mean, we kind of cover that a little bit, right? You can have as many hidden layers as you want. You can have as many nodes as you want. There's no rules to it. Now, all of you are still correct in the sense that you have to declare how big the layer is, right? And you have to declare what activation function you want to use for those nodes. So I'm looking at Lanry's answer, and he's right. But otherwise, there are no other rules. You can say this network has 5 layers or it has 500 layers. You can say there's 10 nodes or there's 500 nodes. It can literally be whatever you want it to be. So keep that in mind, that when it comes to the hidden layers, you're the architect. You're deciding. There's really no hard and fast rules. There's not a lot of protocol to follow. I mean, what you guys are mentioning is correct, but those are more just the requirements of kind of like the framework, right? That you have to declare the number of nodes, or it can't be a dynamic value, right? But otherwise, it can be whatever you want it to be. So, coming back to some of the questions that were asked earlier, right? Think of it. Let me ask you guys something. If we can design it any way we want, then can we consider the number of layers and the number of nodes to be a hyperparameter? And for those of you who don't remember, when I'm talking about hyperparameters, I'm talking about things that we can tune and we can adjust during our experiments. So Yassine is already saying yes, and he's right. I know that some people would debate my usage of the word hyperparameter there, if you really want to be strict about it, but the design of your network itself can be an experiment. Like, you can say, hey, this data is working okay, but you know what? I want to try doubling the number of layers I have. I want to experiment with that. I want to reduce the number of nodes I have. I want to experiment. You can do that. Those are valid experimentation functions. Or I shouldn't say functions, just to not confuse people. But it's valid experimentation methods. You can do that. You can say, hey, I'm feeling really good about my data. I'm feeling really good about my pre-processing. I think I just need more layers. You can do that. That's valid. It takes a long time. It might take a lot of processing power, but it's totally valid to say, I'm going to mess around with the structure of my algorithm. I like where all my other parameters are at. I'm going to run 10 experiments with 10 different sizes of networks and see where I end up. That's one of the beauties of neural networks. Because you couldn't say that for like a regression algorithm, right? Because you can't come up with more features, right? I keep on picking on regression, but you guys should know that it applies to everything else. But it's totally valid for you to say, let me just try a different architecture. I don't need to go back to my stakeholders for more data. I don't need to mess around with the functions. Let me just try a different layout of layers and nodes. So keep that in mind. Very unique to neural networks. The fact that there are no rules to a hidden layer is kind of like one of the strengths of neural networks. Okay? All right, let's move on. What are the requirements of an output layer? What do you guys think? Now remember, ultimately, we're using these things to, we're using all algorithms to get to an answer, right? So what are the requirements of an output layer? Yeah. Yeah, Yassine is on top of it today. You're fast today, my friend. I love that. So Yassine says to match the number of prediction classes, activation functions to match problem type. Yeah. So what Yassine is basically saying there is you're going to have a node for all of your possible results. Excuse me, sorry. So if you're going to have a binary problem, a yes, no, true, false problem, guess what? You're going to have two outputs. Right? That determines your output layer. But let's say you have let me illustrate that a little bit more, right? So if you're writing like a spam filter where you're taking in the contents of an email and deciding whether it's spam, what's your output layer? It's two, right? It can be spam or no spam, right? There's no in between, right? So your output layer is defined for you because of that problem. Let's say you're taking in customer calls and you want to classify the customer calls according to 5 different departments that your company has. You're going to have 5 output layers, right? Because each one of those, not 5 output layers, you're going to have one output layer with 5 nodes. Excuse me, I'm glad I caught myself. You're going to have 5 nodes, right? Because you're going to have 5 possible answers, 5 possible company departments that phone call, that information was about, and you're going to give an answer accordingly. Okay? But Yassine is right. So your output layer is probably your most prescribed layer because it really does relate to what it is that you're outputting. Rosendo says, do you define the outputs or does that come from the algorithm used? It comes from the problem you're trying to solve, Rosendo. So it's more defined by the number of possible answers in your problem. And I mean your business problem, not like a math problem. Right? So like I said, if you're trying to classify the phone calls, the customer service calls to one of 5 departments in your company, then you would have 5 outputs. Right? So that's not a function of the algorithm. You're going to design an algorithm for that. You're going to design a neural network for that. But the fact that there's 5, that number 5 comes from the business problem you're trying to solve. Okay, you guys with me on that? So let me skip ahead here. Yeah, okay, cool. Okay, so we've already hit on some of these. But now that we've kind of broken down these layers and everything else, what are some of the challenges with neural networks? Yassine says also for activation functions, for example, if we have a regression problem, we have to use linear. Yeah. Yassine, I love where you're going with that. We're going to hit more on that in later weeks, but Yassine is correct on that. Because your output layers still do an activation function, right? But again, based on the business problem you're trying to solve, the activation function kind of be like prescribed for you. Okay? But yeah, thank you for that, Yassine. We're going to cover that more as we get deeper into the topic. So Rosendo, so again, guys, the question is, what are some of the challenges with neural networks? Rosendo says, I would think they take a long time to build. Yeah, absolutely. Yeah, because guys, I mean, I was very flippant in telling you that, oh, I'm going to try 10 new architectures for my neural network. Well, if each one of those neural networks takes you a couple days to build, you just extended your experimentation by like a couple of weeks, right? If you're saying I want to fool around and do 10 new architectures that I've never tried before, yeah, great idea, but what does it do to your timeline? Do you have the time for that? So yeah, Rosendo's on the right track with that. Vitor says, I think one challenge is to explain the construction for other sectors, people in a company. Yeah, absolutely. Absolutely, Vitor. This is one of those things where you can decide what it looks like, but it's not always going to make sense to everybody else, right? Landry says needs a lot of data. Yeah, absolutely. That's another potential challenge with neural networks. But Landry, at the same time, I would challenge you though, right? What is a lot? A lot is a relative term, right? So it's really just kind of dependent on what you're trying to solve in the problem, right? But what is a lot? For some problems, a lot of data is 1,000 records. For other problems, 1,000 records is nothing, right? So keep that in mind. Keep that in mind. Okay? Leo says that's why soft skills are also valuable. Yeah, absolutely. Thank you for that, Leo. Kago says one challenge could be we sometimes don't fully understand how the model arrives to its predictions. Yeah. Yeah. Kago and Beecher, you're giving very similar answers, which is absolutely correct. Starry Vibes, it says local minima and saddle points. Yeah, absolutely. So we'll get to this a little bit later, but what Starry Vibes here is referring to is the process that a neural network goes to converge on an answer, right? The learning pattern, as we'll see later, of a neural network it's not linear, or it's not continuous. Is a better way to explain it. Just because it did good here doesn't mean it's always going to do well. It kind of goes in cycles, right? So the minimas and saddles that Starry Vibes is referring to is that until you do a lot of experiments over and over again, you never know if that network still has the possibility to increase its learning and its accuracy and all its metrics or not. You could just be in a saddle. You never know when you're actually at the network's final possible strength or minima until you do a lot of experiments, right? And in some cases, not all neural networks recover from those saddles. They kind of just stay there, right? And that's when you would have to play with more data or different types of nodes, different layers, so on and so forth. But it can be a little bit frustrating in that regard, that you never really know when you're at the network's highest potential. But we're going to get to that a little bit later in the series. But thank you for that, Starry Vibes. Osama says it has a mathematical basis, linear algebra and calculus. But Osama, all algorithms do, right? Maybe not linear algebra specifically, but all algorithms are based in math, right? I mean, that's kind of unavoidable, right? Landry says need GPUs, which can be expensive. Not always, Landry. Not always. So guys, I realize I may have misstated this earlier, and I just want to make sure of this. GPUs are definitely beneficial for neural networks because of the parallel computing, but they are not, I repeat, not a requirement for neural network development. I have done and deployed many, many networks on CPU alone. So it helps, GPU helps, but it is not a requirement for neural networks, okay? And I also say that because I don't want to discourage any of you from working at home on this. I don't want you guys to be saying, oh, I'd like to learn neural networks, but I don't have a GPU, or I can't afford to pay for a GPU on Amazon. You don't have to do that. You can do plenty on CPU, okay? Osama says high cost in time and compute. Yep, absolutely, Osama. Landry says choosing the right setup, basically everything you just covered, number of neurons, layer. Yeah, Yeah, Landry, you're absolutely right. And it kind of ties back to Starry Vibes comment also. You just never know. You just never know when you're at that best model, right? So doing that setup and kind of starting from the ground up and saying, I guess I can do 5 layers. I guess I can do like there's no guide, right? So yeah, Landry, you're right about that. The fact that there is no like prescribed structure can kind of like make you feel like you're stumbling along at first with neural networks, right? So yeah, that's definitely another concern there. Leo says, especially if you're working under 20 gigabytes. Maybe. I don't know, Leo. I have a hard time in any problem, in any data science problem, just giving like a file size or a data size, because are we talking about data that has 5 fields or 500 fields? Because if you have 500 fields, then 20 gigabytes might not be a lot of data, right? That might not be a lot of records. But if it's only 5 fields, then 20 gigabytes might be more than enough records, right? So I don't know, Leo. I'm tempted to say that's problem dependent, not necessarily. Like I don't think there's like a heuristic number, right? So yeah, I don't know if I'm comfortable saying 20 gigabytes or any number of gigabytes. Osama says difficult to explain decisions. Yep, not very explainable. Not very explainable. Manoj says only when training large data we need GPUs. Yeah, Manoj, absolutely. But again, I would encourage you guys that number is a lot bigger than most people think. Because again, same question that I asked Landry. What is large data? Like, what is large? In one problem, large will be much different. Large will be much different than another problem, right? So yeah, so it's all relative. But again, my point here is not to debate that with you guys. My point is that I don't want to discourage you guys from continuing your learning, from developing your skills, without, because you're saying, oh, I heard it's complex and I need GPU. No, you don't. You'll be fine with CPU. Keep learning, keep working, keep developing your skills. You'll be fine. So that's really why I'm saying this, right? That yes, you do need GPU, GPU does help, but it's not an absolute requirement. Okay, so definitely don't be at home sitting on your hands just because you don't have GPU. Do it on CPU. You'll be fine. You'll be fine. Okay, I want to make sure. Let me just read through one of these a little bit more. Give me a second here, guys. Give me just a second. Because I thought I had one more item I wanted to cover with. All right, I think it'll come back to me, but I thought there was one more item I wanted to cover on the challenges. Thank you, Leo, for the updated keyword list. Appreciate that. All right, let's keep going. If it comes to me, I'm going to stop mid-sentence, but I thought there was one more thing I wanted to cover. All right, so I'm pretty sure this is my last slide. Yeah. So one thing I want to leave you guys with. Where does neural networks fit in the grand scheme of things, right? So if we think about data science as a collection of like these big study items, I think it's fair to start with statistics, right? Like just understanding numbers. The second level would be like analytics, right? How do you make those numbers mean something and like, get insights from your like, initial form of numbers, right? And then from there, you're getting into like machine learning, right? Like modeling, essentially, right? Because analytics aren't always models. Analytics aren't always forward looking, right? They usually don't do great outside of their established range. But that's where machine learning comes in, right? And is able to make predictions and whatnot, right? And then after that, it's kind of like neural networks, right? Like neural networks is still modeling, but it's like massively bigger and more capable than most machine learning models out there. Again, not trying to poo-poo machine learning models, and we should always keep an open mind to it. But this is the progression that I think is fairly standard for most people to follow as far as like how they develop as data scientists. I'm not proposing this as a study roadmap. I'm just saying that in all the skills you could develop, this is, I think, a fairly standard stack for most data scientists. And the reason I kind of wanted to close out with this for you guys is because kind of sharing my own experience. This is basically like kind of like the learning progression that I followed, but I felt that like in my own understanding, in my own like usage of data science in general, it really took a step forward when I started understanding neural networks. Like, because if you don't know anything about neural networks and you're at the machine learning phase, you're basically learning like that, like the ISL book, right? Like the Introduction to Statistical Learning book. That's essentially a machine learning book, right? And it's like, yeah, okay, I kind of get that, and I understand why you need clustering and why you need to do dimension reductionality and stuff. Like you like I kind of like understood it, but once I understood neural networks and the inputs and the layers, and it can be whatever you want, and it represents the human brain, that's when I was like, whoa, like mind blown. Okay, now I get why people are so hyped up about data science. So that's why I wanted to kind of share this with you guys, because I want to get you guys excited about it. Because for me, that's really when like I really felt like I was taking steps and like leaps and bounds forward, right? Because like when you're studying like the other stuff, don't get me wrong, obviously it's powerful and I still use it and it's very interesting. But I was like, okay, yeah, like I guess this is feeling like innovative, right? But not really, right? But when you start learning about neural networks and the different nodes and the different functions and just the way they're used, then it was like, oh, okay, I get it. Like I understand why people think that data science is going to be the future. Because remember, for me, this is like 10 years ago, right? 10, 12 years ago. But I'm hoping that the same thing will happen for some of you, because it's kind of like, okay, yeah, like neural networks are pretty powerful, right? Like you start seeing that. And I think you'll start seeing that as we dig more and more into these, right? Where you can start saying, okay, yeah, like I'm getting it. Like I'm understanding the power of data science. I'm understanding why NVIDIA makes so much money and why these models take so much time to train and things like that, right? So I'm hoping to be able to kind of pass that on to you guys, because it was really transformative for me to learn about neural networks. Like I was already excited about data science. I was already passionate about it, but neural networks was like, machine learning is like level 7, neural networks was like level 20, right? As far as like my excitement level, my understanding of the power, my understanding of what I could do with data science, right? Because you can take a problem, you can understand like why you would need clustering and things like that. But neural networks, I think, feels a little bit more real world, right? Like you can see how you would use neural networks for like any number of things in your life, with fairly little effort, right? So that's why I wanted to share this slide with you guys, so you guys understand that I think that that's really kind of my goal here, to help you guys understand the power of them and why they're so different than regression or nearest neighbors or something like that. Okay. So based along those lines, and just like Leo recommended it earlier, this is the book. If you've seen my content before, you guys know that I'm really huge on this book. To me, this has been one of the most influential books that I've read in my career, like as far as understanding neural networks, right? And I'll give you guys the same advice I've given every time I display this book. If you want to know neural networks, well, first of all, keep on coming back, because your good buddy Dennis is going to teach you neural networks. But if you really want to do neural networks, do the same thing that I did. I went through this book and I did every single code example. He shows you how to do neural networks without any frameworks. He actually shows you like the math behind neural networks. And it's not overly complex, there's a couple sections, but it's not too bad. But that's what I did. I went through and I did every single example that he has. And then when you finish the whole book, turn around and do the entire book again, but this time do it with a neural network framework like Keras. Because that's how you'll actually be doing it, right? Nobody actually does the math in neural network anymore. It's unnecessary. You're going to use a framework. But if you really want to understand neural networks, do that. You're going to go through the book twice. The first time, do it just as he wrote it. Do every single Python example and all that. Get the code to work for yourself. Make your own changes. Do your own experiments, blah, blah, blah. Understand what that code looks like. And then turn around, start from page 1, and do every single example, but this time using Keras. Because that simulates the real world, right? If you can do that, go through that book twice like that, you'll be well on your way to understanding neural networks. But of course, keep on coming back to this series, right? I think we're going to have like 3 or 4 more in this series. I don't know yet. But this book to me was really helpful. I mean, I'll keep on recommending this book until the day I die. It was a really good book. So something for you guys to keep in mind, okay? So Kago says, in what situation would a traditional machine learning model perform better than a neural network, especially when it comes to accuracy? You don't know. You don't know, right? That's why you do the experiments, right? Yeah. So guys, obviously I'm hyping up neural networks right now, but I am in no way trying to poo-poo machine learning or anything else, right? So Kago, you don't know. That's why you run the experiments. But then again, as I tell people, that's the job of being a data scientist. Like that is your job. Your job is to conduct experiments on data, right? So there shouldn't be a hard and fast answer, Kago. Like you don't know. Every problem is unique. I can't talk all of a sudden. Every problem is unique. Every data set for every problem is unique, right? So you don't know the answer, Kago. But that's part of the beauty. That's why we're hired. We're hired to run experiments exactly like that. So Vitor says, so then data science can be a natural step to data analysts, or is a different path at all? It can be a natural step, Vitor. So Vitor, I know you're kind of new here, but as I always tell people who ask for career advice, a data analyst is basically the biggest step up between a data analyst and a data scientist is modeling, right? Most data analysts aren't good at modeling, but data scientists are. That's kind of the job, right? So yeah, so Vitor, you're on the right track in the sense that a data analyst can be a natural step, and the biggest part they need to add to their toolbox is the modeling side, right? Because most of your traditional like business analysts, data analysts, financial analysts, they only know the basics of modeling, not the deep stuff, right? Rosendo says, "Thank you for sharing. I would like to have my mind be blown. I would like to have my mind be blown like that." Yeah. So I'm hoping it'll happen for you guys. I would love to inspire that in you guys. I don't know if it will or won't. I'm just sharing my experience. But to me, it was really like transformative to learn about neural networks because it was like, oh, I get it. Like I totally get it now. Okay. Like that was one of those moments for me. Leo, that's exactly right. It's all under the data science umbrella. You won't model as a data. Yeah, that's exactly right. Yeah, so Vidar, Leo's giving you the same answer, right? That the difference is the modeling side. Yassine says situations where we need interpretability and where the problem could simply be solved using statistical methods. No need for complicating what is simply solved. Yeah, yeah, absolutely. Now keep in mind, Yassine, that doesn't mean that other models or machine learning models are more easily explained. There's plenty of machine learning models that are terrible at explainability, right? Yeah, so let's make sure we leave that clearly, guys. Neural networks are hard to explain, but the problem of explainability is not exclusive to neural networks. There's plenty of models that are terrible at explanations, right? So yeah, so it's not exclusive to neural networks, but it's definitely more common in neural networks. Just want to make sure we're all on the same track with that. Leo says this book is great. Yeah. Thank you, Leo. And I love this book. I mean, Leo is a longtime member, so he's heard me say plenty of good things about this book. But I mean, I recommended this book in my content plenty of times because it really helped me. So I hope it'll do the same for you. The guy has a great writing style. To me, maybe if you don't know anything about data science, the book isn't consumable. But if you're at least reasonably involved in data science, the book is very easy to understand and very reasonable to consume. So I hope you guys find it helpful too. Leo says, for the new people, join the Discord and feel free to keep the discussion there. Yeah, absolutely. Thank you, Leo. So I do run a Discord, because some people want to chat during the week, right? I'm only live on Sundays, but some people want to chat during the week. So feel free to join the Discord. Landry says, so you recommend I should learn how to build an NN at least once. Landry, I'm assuming that you're referring to building a neural network without a framework, like just with code. Yes, and we're going to be doing that in next week's session. That's where we're going to pick up next Sunday. We're already at 2 hours, but that's where we're going to pick up next Sunday. We're going to do it on our own, no frameworks. So yes, Landry, if that's what you're referring to, yes, everyone should do that once, right? Do a neural network with just the pure code, no frameworks. And the Tariq Rashid book, it's up on the screen, does do that. So do that once, go through the entire book, no frameworks, just follow the examples he does, and experiment along the way, right? Make your own changes, make your own enhancements, and then turn around and do it with frameworks. If you can do that twice, you're going to be well on your way. Chet says, how often do you need to do data engineering tasks before doing your modeling? It depends. It depends, Chet. Because data engineering is a big topic, right? But it depends on any number of factors, right? How big is your data? How often do you need it? How often is it updated? But if you meant more about the data processing, because we talked about the data, pre-processing that's needed for neural networks, that can also be dependent. Are you doing a NLP problem? Are you doing a computer vision problem? With NLP, there's different ways you can tokenize. There's different ways you can do lemming and stemming. The tokenization is only one pre-processing step. There's another pre-processing step that comes around the sequencing and the vectors. So it kind of depends, Chet. There's really no end to that. Generally speaking, you want to kind of lock down your dictionary and your tokens. That's something that you typically wouldn't change. You typically wouldn't experiment with that. But you would experiment with other portions of the pre-processing. So unfortunately, there's no hard and fast answers there. And guys, keep in mind, this kind of reminded me of another thing. One of the downsides to kind of working with neural networks or with these like business projects is that a lot of these questions that you guys are asking about, like Chet's asking about the data engineering, or somebody else mentioned about how you don't know how many layers to start with. Unfortunately, a lot of that's going to be dictated to you just by the time that your project in the workplace is allotted. Like sometimes you might just have to say, hey, look, I've been doing experiments. This is the best model I can get, but you're giving me a deadline of today. So this is the best model I have today. If you gave me another month, I could probably come up with a much better model. But if we have to ship today, then this is the best model today. So yeah, keep in mind, guys, that a lot of the stuff we're talking about, just because I'm giving you examples of these experiments doesn't mean you're actually going to be given the time to do them. Sometimes you're just going to ship whatever is available at that time, like because you only had X number of weeks, right? So I kind of hate saying that because it's kind of stinks from like a scientific perspective, but that's just like the reality of you got to ship something, right? And not every project is going to give you infinite time, right? So keep that in mind too, guys. Narena, is it Narena, or maybe just Naren? I'm a data scientist, as my role says now, but I don't feel like one. That's a common thing I get. I get a lot of clients that come to me for imposter syndrome. So if you want to, schedule a coaching session, I'd be happy to talk to you about that. Because I'm guessing you don't want to talk about that publicly. But yeah, guys, if there's something I can help you with in private, you want to talk to me one-on-one, I also offer coaching sessions. I've been building up that side of my business. I have some really, really great clients right now, really people that I appreciate working with. So if you'd like to be one of those clients, feel free to contact me and we can get in touch. But Narena, what you're writing about here is very common. I have a lot of clients that come to me for imposter syndrome or to build up their data scientist skills, or maybe it's their first time like in a formal data scientist role. So what you're feeling is totally common. Let me know, I can help you. Lallman says, if I work on building an LLM from scratch, is that a neural network project too? Yes, Lallman. So guys, this is another reason why I was kind of like really interested in neural networks, is because there are some advanced problems in data science that are kind of hard to do without neural networks, right? Like I had another client who came to me recently and they said, well, I want to become an NLP expert. Well, when somebody asks me that, my immediate question to them is, how do you feel about neural networks? Where are your neural network skills at? Because, in modern NLP approaches, it's very, very hard to be an NLP expert unless you're pretty well versed on neural networks. Like that's just a reality, right? You can't be a regression expert and expect to be hired on the NLP side, right? Like you can't really effectively do NLP with regression, right? So yeah, I mean, that's not a bad way to go about it, Lallman, or excuse me, Landry. No, who asked that question? Who asked that question? Did I delete that question? Weird. That question disappeared from my chat. But yeah, I mean, if you're working on an LLM, neural networks, it'd be hard to do that without a neural network, right? Yeah, Leo is bringing up the competitions. There are definitely some competitions that we could all be making more use of. So Leo is heading up that side on the Discord. So definitely feel free to join the Discord and start up conversation there. See if you guys want to participate. Is it Matari? Matari says, hello, Sir Dennis, and hi, everyone. I really benefited from the lesson as a first-year data science student. I'm really benefiting from your work. Oh, thank you so much. I appreciate that. Thank you so much. Appreciate that feedback. Keep on coming back. Every Sunday, guys. Every Sunday at the same time. Whatever this time was for you 2 hours ago, right? Because we've been going for 2 hours. I usually stream on Sundays, 1500 GMT. So keep on coming back. Leo says, last year Yassine and I did a short study on gold and BTC that ended up being right. Let's keep learning and community working together. Leo, I love that spirit. Love that spirit. Yeah, and guys, it's a good time to be holding gold. If you guys know, I'm a big fan of gold. We've done some streams on it. So yeah, glad that you guys are doing those gold studies, because it's a good time to be a gold holder. Yeah, Leo, thanks so much for all the cheerleading you're doing in the chat. Definitely come to the Discord, guys, as Leo is suggesting. Plenty of opportunities for collaboration there if you guys would like. But yeah, if you guys want to start building a neural network or LLM of some kind, that would be cool. But keep on coming back to these sessions on Sunday. Also, next week we're going to go through doing a neural network without any code whatsoever, right? And then we'll also hit on some of this data pre-processing that we were talking about, because clearly there's some interest there. Okay. So yeah, so thanks so much, guys. Really appreciate it. I think this makes for a good stopping point. Gosh, you guys made me go for 2 hours. You know how hard that is to go from like 0 stream to 2 hours? Jeez. This is tough, guys. I'm gonna sign off. I'm gonna watch my show. I always watch a show after this just to kind of decompress and all that. And yeah, but thanks so much, guys. Keep on coming back on Sundays, 1500 GMT. Closing words here. Leo says there's no better place than here and better person than Dennis. That's a fact. Oh, I appreciate that, Leo. Thanks so much. Really appreciate that. You know, like I always tell you guys, I'm just trying to put out good information. You guys know I don't sell cheap courses. I don't, I don't ask anybody for money. I don't, ignore any scams that tell you I'm asking for money, because I don't do that. It's just not my style. What is my style is I do enjoy coaching people. I work with people one-on-one. So if you'd like to sign up for a coaching session, please let me know. Would love to work with you. I have a great roster of clients right now, and I can't tell you how happy it makes me to work one-on-one with you guys. Starry Vibes says, we truly appreciate your guidance. This session has been incredibly informative. Thank you, Starry Vibes. I'm glad you found it informative. But it always worries me when the students tell me that, right? Like, wait a minute, like I shouldn't be your teacher. Like, don't you guys have your own teachers? What are they teaching you guys? But thank you, Starry Vibes. Always good to see you guys. Thank you for the learning. It was very great. I appreciate that. Thank you, Vitor. I appreciate you coming by. I think it's one of your first times, but keep on coming back, Vitor. I appreciate you. Rosendo, appreciate it, Dennis. Thank you, Rosendo. Michael, my good friend Michael, such a great supporter. Thank you so much, Michael. Thanks for the class, Dennis. Thanks for being here. Thanks to Michael. Thanks to everybody. So, guys, as always, like I say, I worry about you guys. It's a dynamic world we're living in. So, please, take care of yourselves. Take care of your families. Keep on coming back on Sundays. Really appreciate you guys, and I'll see you guys next time.